today too.
Okay.
I was learning good in history. I'm thinking I'm gonna have a good day.
What did we learn in history? You wouldn't learn nothing.
I was paying attention to what she, how
I was too, but she would be mad.
Yeah, how them people were getting killed.
I was like, nah, I was finished.
Cam.
I finished some shit that would piss her off, but I
Hey
did.
Cam, is your phone not up here yet?
I'm in 16.
Oh, it's Hobson.
I was gonna say, which over his period did it piss you off, or they were playing just dance all the time? Cause she sure wasn't a bad move.
Hobson 17?
Yes, sir.
Okay. So we need our textbooks out.
You need to have 55 of them.
Huh?
You need to have 55 of them.
55, is that your jersey number?
Yes, sir.
Okay, well, I don't have that many cell phone pockets, don't need that many cell phone pockets, thankfully.
Seems like it.
In the textbook, we need to be on page, I think it's 111 or so. Somewhere with this activity 2.2. Come on, Eric, good timing. Time to get started.
Man, let me have the tell for today, man.
Hey, Hobson,
You gotta get up.
where's your papers from the textbook?
It's all your water, it's 4 ways.
Hobson,
Go.
where's your stuff in the textbook?
Hold up.
Okay, dude, you're gonna break that chair leaning that far back in and sit up.
Sometimes Tommy be on the ground.
Okay, I don't feel like I have to buy a new chair.
Man, it's like good.
It's not great, but it's better than having to buy one.
I'm buying about 4
There's not cheaper than it.
They're expensive. Alright. Oh, come on, Cam. Don't do this.
Okay, you done flat. That's it.
Listen, he ain't smart.
I'm finna bring the chair up there.
No,
Come on with it.
come on up here.
How about I record for y'all? I do no work.
Hobson, come on, it's already
What is it?
recorded.
It's just this paper?
That's just the first page.
Yeah,
We
you
didn't
said what?
quite finish
What
yesterday.
page?
I done told you I lost it. Where'd they go?
What page does that say? 110.
There it is.
Eric, you have your textbook, right? Hobson has his textbook.
This another one?
Chase.
I just wasn't having
That's
fun.
right, you don't have your textbook.
Oh, we start moving,
We what?
we closed on the house today.
Oh, good.
Yeah, we closed on the house today at 4.
Yeah.
Hey, y'all can move.
Yeah.
So you want to TCU?
No. I'm not even gonna try to go to TC. I really don't want to for real. We went to SEDs.
Hey, please stop. One, that just got recorded. Two,
You did.
no. Two, how far did what was the last page I gave you, Chase?
You gave me all them.
Hobson. What was the last page I gave you?
114?
114.
1.
Okay.
114, yeah. Why are you recording this again?
Because I forgot to record a second.
Weirdo.
Hey, Cam.
Now they're YouTube
My pencil
channel,
up
they're
there.
talking about that. That was weird.
What?
You don't got my consent, cool, recording.
This one,
It's working. I've been signed that thing.
Let's see what he was talking about.
on Camcord?
What page you on?
The one with the trapezoid.
Trapezoid.
Alright, we're on.
You can free our Kelly, nigga.
Hey,
That's
Who you doing? I'm tripping, man. Stop. You can't record.
look. Did we finish summarizing the characteristics
Yes,
of
sir.
the basic
Yeah, we can do
exponential? You don't even have anything written down.
Because I ain't writing the book yet.
Can someone else show? No, we didn't.
Yes, we did. He just did get all of it. I got all of it.
I got all of it, so.
I'm the boss out here. Watch out, too.
No, I got it.
So he did not quite finish it.
Bro, he's tapping. You did it at the end of class. They just didn't write it down. It's a hack.
Brown.
No, I read
I-
everything. I mean, wait. You kept going after we.
That's what I'm saying.
Okay, hold on a
I
second.
had to pack up and go. F, R, E.
Thompson, you check him out.
Here are the later pages we'll use today. So, remember if we looked at the basic exponential growth, it looked like this no matter what the base was. Exponential decay, it looks like this no matter what the base was, as long as it was greater than 1 for the growth, or between 0 and 1 for the decay. You're all right, we did have all that.
Wait, give it
so-
to me. Yeah.
Here, I'll just rewrite it up here.
Here. I'm gonna pencil this in, but I think it. Look, no, it's not. Flip it in here.
Say, man.
Yeah, all of a sudden everybody has a I'm gonna shut that crap. He was like, you ain't doing
Hey,
no
Canada, do you know college coaches look at skinny videos? No. Crazy, man.
Someone gotta watch it, cause I know it. Oh, yeah, never mind. Students could be watching it, I can't see that.
But the college gonna be like, oh my god, hey, Mr. Kenny, how does Cam do in class?
Good.
Nah, he gonna put up the video.
Now, what you gonna do if one of them things get like millions of views?
I don't, unless something just terribly goes wrong and I didn't catch it, that's the only reason why it's
They
gonna
might
get
pay
billions of
They might
views.
pay for that though.
Alright,
What, me saying TC got a lot of STDs?
No, why you say you?
why are you this way?
Oh my god,
That's not true. Okay, we'll stop.
It is.
What questions do we have about these features? We did write these down yesterday. Are there any of these that we need to ask questions about today before we get started with today's lesson? Say again, sir?
I thought you was lying when you said you hurt your hand.
I just send it here. I got.
Yeah, let's do that. Let's take pictures of someone else's notes after class, just to make sure that we don't
Everybody gonna take a picture. please?
have,
uh,
a phone in class. Okay. So we all get on these features. Okay. Does anyone remember what we mean by an asymptote?
Thanks, yeah.
It was line or a curve that a function what did it say?
Approaches
Yeah, approaches
at
things.
some infinity. And so remember, like here, as x goes to positive infinity, what's the curve approaching?
So
What's this line though?
oh, the x-axis.
The x-axis, which is y equals 0, or y equals 0. Same thing over here, as x goes to negative infinity, it's approaching the x-axis. So there's a lot of features that are very similar between these two functions, almost identical actually, except for exponential growth is an interval of increase from negative infinity to infinity. The interval of decrease on the decay, though, from negative infinity to infinity. Sound good? Thanks, Eric. I appreciate you.
Yes, sir.
I
Thank you,
shook my head, yeah.
Okay. I just,
No.
I'm just erasing this dude. So I can erase all the growth, right?
Yeah.
He's gonna work numbers, Kenny.
You got it all? Okay. So today we're going to look at something called the compound interest formula. It is a type of exponential growth or decay. So compound interest. A better way to talk about this though, because it doesn't, if we're talking about interest, we're specifically dealing with what type of numbers or what type of idea.
Who we don't know?
The beginning of activity 2.2.
Page numbers?
It should have been one of the pages you already had.
What they?
Awesome, where's the pages you already had? 111, right? Yeah. Page 111, should have been one of the pages you already had. Wait, Hobson, you wrote those down on the wrong page. Yes, you did. These were supposed to go there. We're gonna write something down here later.
It's time we go to sleep too.
Now, page 111, okay.
Along with the John, Betty Jo, and Lizzie at the bottom.
Yep. So compound interest, what are we talking about when we talk about interest? No. I can see what you're saying. but it's actually Eric's favorite thing to talk about.
Money.
Interest rates deal with money. Come on, Eric. Right. Huh?
The market jumped from 3% to 6% in a month.
Really?
Yeah, when we started looking for a house, it was 3. When we bought this house, it was
Okay,
6.
about mathematics.
When I talked
That is
about
math.
money yesterday, you said I was wrong.
It's true, but this time we are talking about money. Notice, literally, look at the context up here, Eric. Helen is opening her first savings account and is depositing how much?
$500.
$500, right? We're dealing with money. But this compound interest formula more as a whole, so that to be able to make it work in more situations, what we're talking about is periodic, exponential
That don't sound like no brownie.
change. Hey, please stop and listen.
Smell like brownies.
So,
You forgot the L egg.
thank you for catching that. So the compound interest, the periodic exponential change, what we mean by periodic is that it's happening or happens at regular intervals.
Like a period in numbers. Like,
Not quite. So,
like a dollar period.
so periodic deals with happening at a regular interval. So monthly pay is periodic, right? I get paid once a month. Or Chase, you get paid weekly or bi-weekly?
Bi-weekly.
Bi-
If I pass, it's gonna change.
Right, but right now, Chase gets paid every 2 weeks. That's periodic because it happens at a regular interval every 2 weeks. Does that make sense? So when we talk about periodic exponential change, we're talking about it happening at regular intervals. The equation when we have periodic change, exponential change, is A equals P. Notice that should remind us of Y equals A times, remember how it's B raised to the X for an exponential function? We just have a different base for here. The base is 1 plus R divided by K raised to the K times T. Which that looks super complicated, but it's not. We're going to break down what each of those pieces from that equation are, and we're going to use it a few times. Sound good? I'll go ahead and tell you this. I know this will sound really weird. This is one of the few equations I'm not going to force you to memorize. We don't have time for that. You will just have, I'll give you the equation, you'll have to know how to apply it. Make sense?
All right, already doing
It's already on there. Look to the right of that page. On the right side of that page. You see it over there? So what do I mean by P?
periodic.
No. Read, it's on there, it's on the page.
Push P. Capital P. It's a, you don't say P.
Yes, it does.
Represents the initial amount.
There we go. P is the initial amount. Now, that initial amount, when we talk about investing money, is known as a principal. Okay? So that's why it's a P with compound interest, because it's the principal amount, or the initial amount. Okay? What do we mean by R? No.
Interest rate.
Read.
Interest rate.
Which one you said? You said what?
R.
R. Yeah.
Interest rate.
K.
Now, hold on before we get there. What we mean by that is if you have a 5% interest rate, or Chase, you just said you'll have a 6%?
Yeah.
Okay? So if you have a 6% interest rate, the way we're going to write that 6% is actually as a decimal. What would 6% be as a decimal?
0.6.
Y'all agree? 0.6?
Yeah.
42.
Okay?
Actually,
So-
if it was 6.0, it'd just be like 60.
Okay, so it sounds like we're not 100% familiar with percents to decimals. So y'all need to pay attention and take notes on this. So 6%. How do you spell percent?
P-R-C-I.
C-E-R.
C-E-N-T.
C-E-N-T. What mathematical operation would go with
Per.
per? But what operation would that be? Addition, subtraction, multiplication, division?
Per person,
Multiplication.
20 per.
Why do you think it's multiplication, Austin? Per person?
Per people.
Well, so notice if it was like $5 per person and you had 20
That's
people.
addition, right?
Well, if you had $5 per person,
With 20 people.
Multiplication.
hold on.
Percent is one word.
Hold on.
Mr. Q is
I know. Weirdly enough, there's a reason why I would split it up into two different parts. You'll see. $5 per person. Now, if you have 20 people, you would end up multiplying those because the units would cancel. But what's the per? $5 per person. What operation is that per?
multiplication.
Per.
Bro, what is that
Per.
operation? Division.
Oh, I was thinking about the inverse.
But, well, what you're actually probably thinking about is, y'all are used to a case where it's $5 per person, well then, how much is it for 20 people? And you do multiply the $5 per person times the 20 people. But I'm just asking, the word per itself is division, okay? So then, at 6, divided by, cent, what should that make you think of? What number? Not really, cent.
6 cents.
Let me ask you this, how many cents are in a dollar?
4.
How many? 100 cents, right? 100 pennies? How many years are in a...
He didn't know that.
What?
He said 4.
4 quarters, right? But how many years are in a century? 100 years. There was a Roman, which comes from a Latin word, but there was a Roman thing called centurions. Any guesses how many soldiers were in a centurion? 100. Whenever we see cent, we should be thinking about 100. So 6 divided by 100. So look at it right here. How many times should that decimal move? Right now, look guys, it's 6 point. How many times should the decimal move if I divide by 100? There's 2 zeros or 2 tens, so it's going to move twice.
It's 0.06.
0.06.
I was about to push on that, but I was like,
You should have done it,
Why you push on?
right?
Cause you ain't pushing people.
Okay, so does that make sense? And this is why I broke it down that way, Chase, of per and cent, because literally that per is coming from the division side,
I should have.
and then the cent is 100. That is the creepiest look I think you've ever given me. I don't know if I can recreate it. Is that creepy? So make a note to yourself about that breakdown for percent. Right? It is division by 100. And so I would make the note that that decimal is going to move twice.
Right, we're supposed to be writing on that one.
No, this is just an extra note so that you can convert percents to decimals. So what do you think 13.5% would be as a decimal?
0.135.
So as a decimal, 0.135. Notice that decimal had to move how many times? Twice. Right?
I ain't gonna lie, class boring when I miss pointing now, bro.
I'm sorry you feel this way.
All she was sat right there.
Yeah, it was frustrating.
Nah, it's really
times.
boring without Ron and,
Jay.
yeah, well, Ryan.
Jay didn't make it interesting, just Ryan did it.
They getting tall.
Okay.
Answer the question.
So, let's look up here. Helen is opening her first savings account and is depositing $500. She decides on a bank that offers a 6% annual interest to be calculated at the end of each year. So, there's one more thing. K and T actually. What does K stand for? Huh? K for cash? You know, cash starts with a C, right?
How about K for kangaroo?
No, for kilo.
How about we read the notes on the page?
The number is the number.
It's the number of
compounding
compounding
periods
periods per year.
Number of compoundings per year. And we'll get into more about that later.
What'd you say?
But if you're only compounding once a year, what's K going to be? Okay. If you're only compounding once a year, what's K going to be? 1. Let's say you're compounding monthly, how often, what's K going to be?
That's a period right there.
Say again?
It's monthly, right?
Monthly would be 12, right? 12 months in a year?
Say 10.
Leave them alone. So then what do you think this T stands for? Time. Okay. So those things are what we need to be aware of when using this equation. So, A of T.
Oh, hey, dude.
Hold on.
What?
You got it, CJ. Do it again. Clean, you got to do it again.
That is so long.
Oh,
You feel your eyelids?
Nope, don't want to see it? Alright. So, number 1. Write a function, A of T, to model the amount of money in Helen's savings account after T years. So, A of T equals what? What's going to be that value for P?
The initial amount.
The initial amount, which is?
1 year, 5 years.
1 and 5.
How much is she initially investing? Isn't that?
Oh, $500.
Thank you, 500, right? That's my initial investment, or her initial investment. Times, what comes next?
1 year.
Not 1 year. Look at the equation
1.
of 1. That's not even a variable, it's just 1. Right? Eric, what?
I mean, I said it.
I thought you, no, you said 1 year.
It's a word year.
But no, that's not what's happening. You don't just say like, oh, I'm sorry, I said the completely wrong thing. I just happened to have the right number.
But what the 1 stand for the year, right?
No, that's a good question. What does this R stand for again? Rate, which is a percent, correct? Now, if you have, because you always start with the entire thing, right? What percent would represent everything? Listen to the question again. Stop. What rate would represent when you have everything there? 100%, right? What would 100% be as a decimal?
100.0.
Not 100.0. Remember, that decimal needs to move how many times?
It'd be 1.
So it'd be 1. That, Eric, is where the 1's coming from, is representing 100%. And if you are increasing it, then you add R. Does that make sense? So like when Helen first invests her money, how much does she have? 500. She has all of it. And then it's going to increase, which is why we're adding R. So that's a good question. All right? So 1 plus, what's R going to be?
0.06.
Good. 6%, but that's 0.06 divided by, what's K?
What?
It's 1. Notice, how often is she getting it, her money compounded?
1.
Where'd it go? It says it up here.
1 year.
1 year, Mr. Kenny.
Oh yeah, calculated at the end of each year. It's right there. All right, raised to, K again is 1, times, what?
0.06.
What's the thing after K?
Oh, T, my bad.
T. Now, we're going to eventually substitute in a 1, but don't we want a function where T is the independent variable? So raised to the T. All right. So, now we want to find 1 year. A of 1 equals what? How am I going to figure that out? How about y'all focus on your education?
It'd be
You got nothing. Ain't got it.
Well, remember, the whole thing is we wrote a function to represent the money, but now we need to look at the end of 1 year and at the end of 5 years.
so it'd be 5 on the next one.
We haven't done the 1 yet. We haven't looked at 1 year. Guys, what is that 1 being substituted in for? T, the time. So,
So that means what, 1 year, only 1 minute?
not 1 minute, 1
Year.
year.
1 year.
We got
Yeah, I just, life.
Brown.
So put that into the calculator, figure out how much money she is going to have after 1 year.
Yeah.
She's not gonna have 1,000.
So it can be
Not all of them, dude.
They put that in calculator.
We play way too much in this class, and by we, I mean you.
Who we? What you talking about?
You know who it is.
I don't know what you're talking about.
So put it into the calculator, figure out how much money she's gonna have after 1 year when she has a 6% interest rate.
Mickey, why you should be recording?
$530.
530 for the first one? Why am I still recording?
Yes.
In case a student chooses to step up their game.
It says log in.
We're gonna stay up there.
You don't need to
So
log
you
in.
get noticed.
Decides that they wanna put in a little bit more effort, or if they miss a day of class. You don't need to log in, you just need to go to a calculator page, Eric.
So Miss Ken, how do I do that one time, one time? On the computer, on the camera.
Okay, let's just do this.
Do you record every day?
Mm-hmm.
It's just not every day during the class.
Yeah, it's usually during,
It's big
Second.
class. No, it's not. There's no people in it. It's small. It's as small as this one or smaller.
Okay, so notice, Khalil, we have the 500, open the parentheses, 1 plus 0.06 divided by 1. You're good through there?
Yes, sir.
And then you have the exponent,
Wait,
I put E.
did I do something?
not E, okay? So notice that's specifically E raised to the x. We're not using E right now. What we want is just an exponent. That's this little caret symbol on the far left, right above E. And then you would just literally type out 1 times 1 for the first one.
Yeah.
Now, I will point this out because this should make your life easier. Instead of having to type it all the way back out, what can we do?
Simplify.
Scroll up,
To Indian president.
Right.
and once it's highlighted, hit enter, and that 1 is going to change to a
Wait, did I type it in?
I'll come and look at it in a second.
Oh, never mind.
Okay?
See something, see.
5 years is gonna take that long?
It depends on the. I'll tell you this: you will not find a bank that gives you a 6% interest rate. You just won't.
So in 5
Like
years-
half a percent is normal.
I get like 22 cents every month.
Right.
So in 5 years, she's only gonna increase.
You know, and like even if I have like 1,000 in there, it's all you
It
need.
doesn't give you much at all. And realistically, she probably wouldn't even get that much. Now, that's just putting $500 in and leaving it alone. That's why a lot of times people put investments in the stock market because there's a chance of a higher return there. But yeah, savings
Yeah.
account don't give you much.
It's crazy because they won't give you that much of an interest rate.
Okay.
They'll give you a 23% interest rate.
Mm-hmm. Oh yeah, they'll charge you a ton. They won't give you a great interest rate to make money though. But I mean, it's a business, unfortunately. So right here, I mean, not unfortunately, I get it. Number 4, write a function to model the amount of money in Helen's savings account at the end of T years if it's compounded K times during the year. So A equals, what's P again for Helen?
500.
500, so that's still going to stay the same for number 4. Times
1 plus
1 plus, what's her rate?
0.06
0.06 again.
over
Read this information, it tells you.
over T years.
Is the T supposed to go here? What does it say? What's R divided by? K. Not for this problem.
5.
No, read it. It literally tells you.
Come on, Erica.
Hobson, you ain't funny.
No, I'm saying.
I'm glad you think you're funny, but you're not.
Can't admit. You're a teacher, of course you're not. Wow.
I laugh when it's funny. Cam makes me laugh. Chase makes me laugh.
At the end.
In fact, all of y'all made me laugh, just not when you're trying to be derisive. What's up? What do y'all think K is? It tells you, literally, to use what? How many times is it compounding per year?
Periods per year. One.
K times.
Thank you. So what's gonna be in the place of K?
K.
K.
What?
It
And how do
literally says K times per year.
K,
What is
the
that?
K gonna be in the place of K. You could just say K.
I wanted you to recognize
Man,
that it's K.
Man, how you went from,
Wasn't
how you went
K
from
one
one
last
to
time?
5? You 1 to 4.
Well, we did 1 and we did 2, didn't we?
No, where is
Did we skip 2? It's on the back of that page.
Wasn't K one last time?
K was 1 last time,
One time per year.
but this problem specifically says compounded K times per year. Why are you confused? It's a different, it's connected, but it's a different problem.
He's not writing it down, that's why he's confused.
You know, we're on this number 4, right? Different problem. She's still investing $500. She still has a 6% interest rate, but we're about to see what happens when you change the number of compoundings per year. That's what you need to recognize.
Did we just make that interest rate up?
Mhm. Well, they gave it to us in the problem. If you looked above number 1, they told us it was 6%.
Oh, the market just has to be 6%.
So what's this raised to? What's the exponent? Look at the equation.
K.
K, which is what in this case?
K.
K. Times. How many years do they tell us?
T.
T. So we're going to use T. Don't make it more difficult than that.
Oh, awesome.
Oh, so this time K is changing.
Now K is changing.
Daily?
We're going to look at that in a second. So determine the amount of money in Helen's account at the end of 3 years if it is compounded blank. So looking at the start of that, what value are we given now that we were missing in this equation? Can I say again? Well, if I just look here, it's not K and T.
It's K and 3.
What is 3? Like K is 3?
T is 3.
Time is 3. So now I have which is necessary because now what's the only unknown that I have? Okay. Come on, Lilo. Pay attention. So, if it is compounded twice a year, what is K? Is what? 2. If it's compounded monthly, what is K? 12. If it's compounded daily, K is 365.
That's a lot of money.
Well, let's actually check that out. Substitute those values in for K using your calculator, and let's figure out what it would be. If I were you, what I would do is I would write out the equation first.
I'm gonna
I will come and look at it in a second, but that probably
Yes,
means
sir.
you're doing